Hi, David Peacock here. Now, today we're actually going to be talking about similarity in polygons. And I don't really have a good polygon, but I could talk about similarity using this. So, if I have this, and let's say that we have a similar figure, like, I don't know, this BB-8, then we could figure out the scale factor between the two, and then if I knew the height of this, I'd be able to know the height of that one. Or, we could also figure out the scale factor between this BB-8 and this one right here. So, that's what we're going to be doing today, figuring out scale factor, figuring out what heights things are, figuring out if two things are actually similar. And that's all today on geometry. So today we're talking about similar polygons. So figures that are similar or have what looks like kind of the top of the congruent symbol have the same shape, but not necessarily the same size. That's why it looks like the top of the congruent symbol, because it's the same shape, but it's not actually equal. The sizes are different. Two polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding sides are proportional. So let's look at this figure, which has magically appeared right here. So we can start with the things that we know. For instance, angle E is congruent to angle A. And we know that because both of these are 90-degree angles. We can also say angle D is congruent to angle C. Or not C, angle H. And we know that because each of these has the three arc marks. I can say angle C is congruent to angle G. That's because of the two arc marks. And then finally, I can say angle B is congruent to angle F. So now we've shown that all four angles are congruent. And if I was to go into all of these, I would say something like 8 over 4, which is AD over EH, is equal to 10 over 5, which is AB over EF, which is equal to 12 over 6, which is equal to 2 over 1. So because of that, these all have the same, their corresponding sides are proportional. Each of these have a 2-to-1 ratio. So we could say, in this case, ABCD is similar to EFGH. It is very important that we put it in the exact same order, or else it is not a correct similarity statement. So ABCD would not be similar to EHGF. All right, so now we are going to identify pairs of congruent angles and corresponding sides. So in this case, I know that, let's see, angle Q is congruent to angle Y, and that's because they both have the two arc marks. I know angle Z is congruent to angle R. That's because of that. And then by third angle theorem, angle S has to be congruent to angle X. So we have our three angles are all congruent, and now let's just actually identify the congruent sides. So that means XY should end up corresponding with, well, XY would be the same as SQ. Just to confirm, SQ was 9. So that would be something like 9 over, let's see, 6 over 9. Then we would do something like, let's see, XY, so let's do XZ would be the same as SR. So XZ is 9 over 13.5. And then finally, we would do the 12 over 18 for RQ. Sorry, not RQ. RQ would go on the bottom. But we would say something like ZY over RQ. Wait, I don't put the lines. These are measurements. All of these will simplify to be 2 over 3, which means that they are similar. That right there is what we actually call a similarity ratio. A similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. So in this case, ABC is congruent to DEF. It's also congruent to EFD or FDE because in reality, as these are both equilateral, it's similar for all three sides. But the ratio in this case would be 3 over 6 or 1 over 2. So that would be the similarity ratio of triangle ABC to triangle DEF. Now here's the thing. If I wanted this, the ratio of DEF to triangle ABC, it suddenly becomes 6 over 3 or 2 over 1. We want to determine if JLM is similar to NPS, and if so, we write the similarity ratio and a similarity statement. So let's talk real quick about what this similarity ratio is going to end up being. So first off, we would say something like we have to first figure out if it's similar. So what we have to do is we have to figure out are all of the angles similar. So angle P is congruent to angle L. We know that because of the mark, the arc mark. We also know that angle M, let's actually go with angle N, is congruent to angle M. And then finally, we would do angle J. Oh wait, sorry, we were using the... So angle S is congruent to angle J. All right, now that we have those, let's actually try doing some stuff. So now that we have that, we would actually need to look. So that would mean if this is correct, LM over PN should be equal to MJ over NS, which should be equal to, wait a second, yeah, which should be equal to LJ over PS. So let's double check that and see if that's correct. LM is 60 over 24. MJ is 45 over 18. And then LJ is 30 over 75. So let's see. Common factor of 60 and 24 is 12. So that becomes 2 over 5. Common factor of 18, or 5 over 2. Common factor of 45 over 18 is, well, 9. So that's 5 over 2. And then 30 would be, oh wait, wrote this last one wrong. 75 over 30. But yes, it would also be 5 over 2, the common factor there being 15. So since they are there, we can write our statement, but our statement would actually be triangle JML is similar to triangle SNP. So there we go. All right. In this case, we actually know A, B, C, D, and E, F, G, H are similar. So what we would say is, actually I like to put the variables on top. X plus 3 is the equivalent of 4 in the same way that 2x minus 4 is similar to 3. So at that point, what do? We cross multiply. So this becomes 3 times x plus 3 equals 4 times 2x minus 4. So what do we get from there? We get 3x plus 9 equals 8x minus 16. Subtract 3x. 9 equals 5x minus 16. Add 16. At which point we end up getting 25 equals 5x. When we divide by 5, x is going to equal 5. And to plug that in, that means that this is 8. And this would be 6. Meaning that the ratio is also 1 to 2 or 2 to 1. An architect is designing a building that is 200 feet long and 140 feet wide. She builds a model so that the similarity ratio of the model to the building is 1 to 500. So what is the length and width of the model in inches? It's questions like this where I'm kind of glad I have a calculator. So in this case, we want to have it that it's 200 feet long by 140 feet wide. So the similarity ratio is going to be 1 to 500. So let's see. They want it in inches. So the first thing I'm actually going to do is I'm going to do 200 times 12. Actually, 200 times 12. So that's 2,400. And then let's see. 140 times 12. So let's see. That's a 0. 4 times 2 is 8. 4. 8. 6. 1. So 1680. Let me double check that I did that math right, because I don't trust myself. 12 times 140. 12 times 140 is, yep, 1680. So if I want the length and width, so we want the model. So the model is going to be, so x over 2,400 is equal to 1 over 500. So that becomes 500x equals 2,400. At which point I divide 2,400 by 500. That becomes 4.8 inches long. And then I do the same thing. X over 1680. Why can I not write numbers today? Is equal to 1 over 500. That means 500x is equal to 1680. Divide 1680 by 500. And that gets us 3.36 inches wide. And that's how you would do those. Now the most important thing, though, is not just how you do those, but also how you like and subscribe. And there you go. All right, I will see you next time on Geometry. Thank you very much. Goodbye.